Greetings, fellow mathematicians. We're going to take a look at another tangent line question where the calculations will be really simple using differentiation rules. Now make sure you're comfortable with the basic form for the equation of a tangent line. Y minus f of a equals f prime of a times x minus a. And that guides you through what you need to calculate. Two quantities. You need a y coordinate, that's f of a, and you need the slope. F prime of a, the derivative, that's how we find slopes of tangent lines in calculus. One of the main ideas in the beginning of Calculus 1, derivatives, those are slopes of tangent lines. So let's go ahead and first visualize this to help guide us through what we're calculating. Our function or curve is y equals square root of x, and that's a pretty simple shape, which you're probably familiar with. The point at which we're looking for the tangent line has x-coordinate 4. So if we go to that point on the graph, our tangent line looks roughly like that, doing a quick sketch by hand. Now if you take a look at that tangent line, it definitely has positive slope, but it doesn't look very steep. So we might expect from our calculations a positive value for slope, but it should be small. And let's see if we get that. So let's jump straight to our calculations. We're given the x-coordinate of our point, so let's go ahead and calculate the y value. So that we just plug into the function. All right, and that's straightforward. We're just going to calculate f of 4. And we get square root of 4, which is 2. So the y-coordinate of that point, which you're sometimes given in the problem, but not here, that point is 4, 2, at which we're finding the equation of the tangent line to that curve, y equals square root of x. All right, so that is your y-coordinate of the point. Now we just need the slope. We're going to calculate the slope of our tangent line by calculating a derivative. Do not use the limit definition, use your differentiation rules. Now here we have square root of x. We can rewrite that as a power, x to the 1/2 power. So let me rewrite that as x to the 1/2. And that's going to make calculating the derivative much easier. So let's go ahead and do that. If that's your function, f of x, let's calculate the derivative. Bring the power down, so 1/2. And we subtract 1 from that exponent to get x to the negative 1/2 now for our derivative in the power. All right, now I'm just going to rewrite that to make the calculations easy. So I have a negative power. I can put that x into the denominator. And since it's a 1/2 power, I'm going to write that as a square root of x in the denominator. All right, and from here, that is our derivative as a function. We're not plugging this in because we want it to be a numerical value for the slope. So take your derivative as a function, and now we're going to evaluate that at 4. So if we calculate f prime of 4, here, plug that in. We get 1 over 2 times square root of 4. And just be careful with your calculations. Square root of 4 is 2. So in our denominator, we have 2 times 2. We should get the slope of our tangent line as 1 over 4. And that is it. We just have to plug this in. Our a value in the general form is 4. So let's write this down as y minus f of 4 equals f prime of 4 times x minus 4. And we just need to plug in the two values there. F of 4, we have that as 2. And we just calculated our derivative, which, as expected, comes out from our graph to be a small positive value. F prime of 4 is 1 over 4. And if you go ahead and just plug those in, we get, as the equation of our tangent line, y minus 2 equals 1 over 4 times x minus 4. And there we go. Now just to make a connection from this form, which is point-slope form for the equation of the tangent line, let's go ahead and solve this for y. So first I'm going to distribute. We'll get y minus 2 equals 1/4 times x minus 1. And it looks like if I add 2 to each side, we get the equation of our line, solving for y, putting it in form y equals mx plus b, slope-intercept form. We have it as 1/4 x. And if we add 2 minus 1, we get plus 1. Now, both of these are equally correct. You might not be expected to go from here to there if you're asked this in your Calculus 1 course. But this should make it a lot easier to identify that it seems to match what we have graphically. Looks like we have a small positive slope, 1/4, so a rise of 1 unit over 4. But more importantly, our tangent line does seem to pass through the y-intercept, 1. And there we go. This is another good example to relate what you're calculating to some basic ideas which you can interpret graphically. Hope you enjoyed the problem. If you did, support the channel, like and subscribe.